Okay. Hello. Am I audible?
Yes, sir.
Okay. Thank you. So this is session one. So today we'll discuss about week 1 to 8. So we'll revise the concept of week 1 to 8, and we'll solve few questions based on that. Okay. And in tomorrow's session, we'll discuss week 9 to 12. Okay. So let me share my screen. Is my screen visible?
Yes, sir.
Okay. Great. So the syllabus for end term exam, right? For end term is week 1 to 8. Okay, so we have all the week content, but if you look at the weightage of week 1 to 8, this is basically around 60-65% you can say, and remaining week is basically 9 to 12 is around 35 to 40%. Okay, so this week 1 to 8 will consist of 6 to 65, and remaining weeks will be 35-40% around, right? This is the weightage for end term exam. And out of this week 1 to 8, week 1 is just the introduction part. So if you go through the slides, that will be good enough. Or if you look at the supplementary content, right? So in that we have quiz 1 slides, right? Quiz 1 revision slides. So in that we have just 4 slides for week 1. So if you go through that, that is also good enough. Okay. Then we have week 7 content that is also mostly based on the web fundamentals and the Python database connectivity. So we already checked your knowledge about Python DB in OP. So you also just go to the lectures. That would be good enough. Okay. So week one and week 7 is not that much important for NTERM. You can expect 1 mark question from these 2 weeks, simple 1 or 2 mark question. Okay, that's it. But most of the weightage will be given to SQL part from week 1 to 8. Then we have normalization, that is again week 5-6, very important. SQL is week 2-3, and we have TRC, DRC, ER diagram, that is week 4. So 2, 3, 4, 5, 6 will consist of also week 8, right? So week 8 is also there. For example, binary search tree, that concept. Okay, so this will constitute of around 60-65%. Okay, so week 1, week 7, you can just go through the slide. That is good enough for end term exam. We are going to focus more on these particular topics in today's session here. Okay.
Okay, sir.
Yes, anyone, any question? Someone raised their hand? No. Okay.
Sir, actually,
Yes.
can you focus on that relational algebra part also? I actually don't understand those questions.
Okay, week 4 concept, right? So we'll discuss
Yes.
that. Yeah, sure.
Okay, sir.
So week 1, week 7, just go through the slide. That is more than enough. You can expect simple 1 mark question. Then we'll focus more on week 2 and 3. So again, SQL part, right? So we already discussed SQL in OPE sessions, in quiz 1 revision session as well. So you can just refer to that as well. Okay. Now we are not going to ask outright the SQL query for this one, but you should be able to find out the output of SQL query, what are the various constraints we have. So you can expect a question based on the constraint and data types, right? So if you look at the topic, what is data type we have, and then we have some constraint, right? So tell me different data types we use in SQL, what we have focused on in the course.
Integer, varchar,
Yeah, integer, then we have varchar
float.
n, then we have character n, float, then we have a boolean also, but we mostly focus this on integer, varchar, character, this one, right? What are the constraint we have? Yes, anyone? Not null. Then we have
Unique.
check constraint. Then we have unique, right? And then we have primary key, foreign key, primary key, foreign key constraint. Okay. Now, if we look at data types, integer we already know. Var char is basically string data type only. But what's the difference between var char and char? Yes, anyone? Difference between var char and character data type? Yes, anyone?
Char will allot a fixed amount of space, whereas varchar can be variable amount of space depending on the number of characters inserted.
Yeah, that is correct. Right. So if you see var char, Yeah. So if you see varchar here, so it will take as name suggests variable. Okay. So variable character of length n, but the storage is variable here. So we are talking in terms of storage, right? So variable storage, right? For example, if I create a two column here like this, okay, one let's say based on name, and then we have course, and name is basically varchar 5, and this is basically a character 5. Let's say we have these two constraints. Now in both the cases we can take up to 5 characters, that is the thing here. But if you look at the values in this course column here, it will be a fixed storage, right? So if I say, let's say for example Ram, then we have Raj, right? And here if I say a course name, let's say for example DBMS, and let's say CT. Okay, so here we have Ram in name, but the what the data type we have used the varchar. So in if you just copy paste this name, you can see we have this thing, okay, Ram only. But if you take a CT for example, in the case of character, you can see CT. After that, you have these three empty space, and then you can see a quotation here. Okay, so you can do one thing: go to our editor, PG admin. You can create these two columns like this in some table, and with this constraint, you can see here, and try to copy the output here. It means what? You can see, even though we have two characters here in CT, but it is allocating what? The space for all the 5 characters here. That's not the case in the case of a varchar here. Okay. I hope this thing is clear.
Yes, sir.
Okay, great. Then we have a constraint as name suggests not null. It should not allow the null values. Then we have check constraint. Unique will make sure all the values in that particular column must be unique. What is check constraint? So if I say we have one more column, let's say for example age, and if I put the constraint check and some condition here, okay, condition. So if let's say for example we are saying check age greater than 21. So if age is greater than 21 in the insert statement, then only it will get inserted, otherwise it will throw an error that check constraint violated. Okay, simple. We use check constraint to verify some condition here, right? Let's say for example I like this. Also, what is primary key, foreign key? Yes, anyone tell me what is primary key and foreign key?
Sir, primary key is the key that individually explains the data set, the table.
Yeah, we can say attribute or key, which is used to uniquely identify the row, right? Uniquely identify the row in table. Identify the row in table. What about foreign key?
It is the primary key of another table.
Is it necessary that the foreign key must be a primary key of other table?
No.
No, right? So either it should be a primary key of other table or any other attribute, but it must have unique constraint, right? Unique constraint. So I'm not talking about the foreign key must have unique constraint. I'm talking about the attribute which you are going to make, that must have unique constraint. Okay, let me write it in this manner. The attribute which you are referring must have a unique constraint. Unique constraint. Okay. So if I see this student table here, I can put a roll number as a primary key, because if I make any column as a primary key, it means what? Automatically it will have not null plus unique constraint here. Okay, that's it. And but if I want to make name as a foreign key in the some other table, so I have to give unique constraint to this particular name. Then I can use this name to name as a foreign key in a different table here. Okay, so the attribute which you want to, which you are referring, must have a unique constraint. This is what we are saying about the foreign key. Okay, but in general, if you see, it's basically a primary key only. Anyone any doubt in constraint and data type?
No, sir.
Okay, great. So let's try to solve one question here. Question 9. Okay, so this is the one previous term question, right? So I guess a quiz one or some question. So here we have a SQL statement. We have a table, roll number, name, marks. So it has integer data type, primary key, character, and then we are inserting the statement in this particular order here, right? So tell me which option is correct here. So if you want to insert any rows in table, we use this insert a command, insert into, we have to specify the table name, then values, and these values will be inserted in this particular column here. Okay. So in this same order, if we want to insert a value in specific order, we'll discuss that how we can do that. You can see here, right? So insert into student, roll number, name, marks. So we can define the attribute in which we want to insert the values here. So tell me which one is correct here.
First option.
Okay.
Yes, sir, first one.
Here we are trying to insert the
Yes, sir.
values in student. So one satisfying roll number, Amit also satisfying the constraint 80. So this is also
Sir,
inserted. All these
option
three are
3.
okay. We'll see. So we have inserted these three rows. Then we'll update the student. Set marks equals to marks plus 10, where marks is less than 85. If you look at it, less than 85, we have this two. So this will get updated to what? 90. This will get updated to what? 80 here. Then we have to delete from student where name equals to Neha. So we are deleting a row which consists of name equals to Neha. So we are removing this one. And then we are inserting student, roll number, name, marks. Roll number is 4, Neha, and marks is 95. So 1 Amit 90, 3 Ravi 80, and 4 Neha 95. So option A will be correct here. Okay. So this is how we are updating the records here. You can see update, then we have to specify the table name, then we have to set that what we want to update in the table, and we can apply the condition here as well. This is how we update the any column we can say, okay, or values. And this is delete from student. So here we have a delete a command, delete from student. So if we didn't specify this where condition, what will happen?
It will delete the all the records.
It will delete all the rows from this particular table. Okay. Now, what's the difference between delete, drop, and truncate? Yes, anyone? We have delete command. We already discussed. It is used to delete the rows from the table. What about drop and truncate?
Truncate will just remove all the records, whereas drop will drop the entire table and its schema.
Yeah. So drop will remove entire table if you want to drop the table. So it will remove all the table along with the all attributes here. What about truncate?
It removes all the rows from the table.
Okay. So
Schema is intact.
Sorry. Yes. Yes.
Schema is there in truncate.
Schema is
Kept.
okay. So can we say the equivalent to delete from student only?
Yeah.
Yes.
Sir, shouldn't it be delete star from students?
No, delete from students only, not star. We use star in select command, not in delete command. Okay.
Okay, sir.
Yeah. So truncate, yeah, this is correct. Delete from student, it will remove all the rows. Drop will remove entire table along with the attributes, everything. What truncate does, it will remove all the rows and it will again create the same schema of the table here, right? So automatically what happens, it will remove all the rows as well as it will remove the uh, schema. Again, it will create the same table here. So basically we can say delete from student is equivalent to a truncate here. Okay. But what happens at the backend, that is a different thing here. Okay. So delete, a drop, a truncate. So I hope any doubt in your data type, constraint, or insert command, update command, delete command, drop, truncate? Yes, anyone?
No, sir.
Truncate will do.
Truncate will remove all the rows automatically from the table as well as the attributes also. And again, it will create the same schema automatically at the back end. Okay.
Sir, for
So-
existing column, we can update us, sir. If not, there means only we can update us, sir.
Existing column. Yeah, we can
Or-
update the values of a column here.
If Ravi is already there in the table, but still I can put a update, set the student name is equals to like that I can put, but it will work, sir. It will work, but it will say no changes, sir.
Okay, so if you put again name equals to Ravi like that,
Yes,
where
yes.
roll number is 3, yeah, it will update. It will not throw any error. It will update the same name here. Okay, like that.
Sir, can we get this PDF?
Yeah, we'll share after the session. Okay.
Thank you.
Yeah. Okay. So I hope this is
Sir, sir, will it be updated on the in the Google Calendar or any other
in the
place?
calendar itself. Okay.
Okay, thank you, sir.
So I hope you understand the difference between delete and a truncate here. So delete will remove all the rows from the table. Same truncate as well, but it will remove the schema as well. Again, it deals with the schema also. So that's why in many references, if you see delete is basically a DML command, okay, data manipulation language, but truncate is basically categorized as DDL command. Okay, that's why there is a difference in the operation, how it works internally. Okay, so DML, so delete is basically DML command and truncate is DDL command. So you can just note this one. Okay. Uh, yeah. So this is about the creating a table, inserting rows, then update, delete. Okay. This is how, like, if we give any statement in any order, you will be able to solve the questions, right? Maybe we can just put here instead of, let's say, for example, name, we just have Payu here and we'll put, let's say, Amitesh here, right? Then it will, you should know that, okay, it will violate the constraint, so this row will not get inserted, okay? The remaining rows will get inserted. Then based on that, your answer will get changed, okay? So please be careful while dealing with this type of questions. You have to check whether it's satisfying the constraint as well, okay? Again, we can put here 1, but once we insert this particular first row, we cannot insert this row as it will violate the primary key constraint here, okay? So this is straightforward, but in some cases we have done that also, okay? So we have, it will violate the constraint or data type.
Sir, drop is DML command.
Drop is also a DDL command. It deals with the structure, right? Whatever the command deals with the structure of a database or schema of a database, that is basically DDL command. We are defining the table, right? Data definition language here.
Okay, sir.
Yeah. What happened? Yeah. Okay. Great. And then we have select a query. Okay. So we have discussed in detail in OP session about all the select queries. Okay. So that's the thing. We'll try to solve few questions here. You can see. Tell me what will be the output of this table here.
Sir, number of rows would be six, right?
We'll see. So here we have two table. Select stars. We have to select all the columns from players. So we have players table. We have left outer join. Okay.
Yes.
So points and then on players name. So we are performing the join based on the player ID here. We can see we are name like J%. So what is J% here?
Starting with
Starts with
J.
J.
Yeah. So this like operator is basically we can say wildcard operator use percentage along with the underscore here. So underscore will take only one character, percentage can take any number of character here. Okay. Now J percentage means what? Name should start with the J and ends with doesn't matter. Okay. Only start and only first letter should be J. That's it. Now we are joining based on the player ID here. So here we have 1, it will try to match with this one. 2 will match with 2, 3 will match with 3, 4 will match with 4. Okay, so we'll get these 4 rows. Yes. Any other row we are going to
Two
get?
rows.
How
Sir, I
many rows
think
we
you
are
get
going to get?
all the rows of the players table, right?
Yeah, it will have null if it's not satisfying.
Yes.
Yeah.
Only
So
one.
here we have left outer join. So how it work? First, based on the matching criteria. Okay. So first matching rows based on condition. Then remaining rows from left table. Remaining rows from left table here. Okay. Left table. This is what we are going to get here. Okay. Now, if you see matching rows are basically 4, then we have remaining rows from the left table. So we are going to get this one, but the values corresponding to these two rows will be a null. Okay. So these two columns will be a null like that. Now we're interested in J percent here. So J percent is basically this one, this one, this one. So how many rows we are going to get?
3.
3 here. Okay. If this is basically simply a join, in that case, what will be the output?
2.
Then it would
3.
2.
2 only, right? This one and this one, because we
5
don't have
IDs not there in
yeah.
points.
Okay. Now what will happen if I just put right outer join?
It will take
Then
all
it will
rows
increase.
from right table and
So
put
it will
it
get
null.
2.
Yeah. So anyway, all the rows are getting covered here. So we are still going to get 2 as the answer. Okay. So this is how left outer join, right outer join works. Okay. Full outer join basically what? Let me write it down here. So right outer join means what? Some matching rows from based on the condition plus remaining rows from the right table. From right table we can say. Okay. What about full outer join? Yes, anyone?
Then 3, sir.
Yeah, so how it works? So first it will give us the matching rows based on the condition, then remaining rows from both the table. From both the table here. Okay. And the corresponding values for the required this column will be null. Okay. If we say for these two cases, the value for this two column will be null in the output. Okay, because we don't have a matching clear ID here. Anyone, any doubt in left outer join, right outer join, full outer join?
Sir,
Yes.
so can we say full outer join is inner join plus left outer join and right outer join?
Yeah, that you can say because output will be similar only, right?
Okay, sir.
This is also you can say inner join plus remaining rows from left table like that. So we have different types of joins here. So we have discussed types of joins. So we have discussed about the outer join here. We have 3 different types of outer join. First
Sir,
one is
answer is 3 na sir for that
yes,
question.
for this question answer is 3. Yeah.
Ah.
Left outer join and then we have what full outer join. Now what about natural join?
A common rows from both tables.
So how it works? It will join the table
Common named attributes.
automatically based on the common attribute, right? Common attributes here. Okay, so we don't need to specify any joining condition here. Automatically it will check for a common attribute and based on that it will perform the join. But what if say, let's say for example, we don't have any common attribute, what will happen in that case?
Cross join.
Cross join.
Yeah. If there is no common attribute within two tables and if we still perform the natural join, it will act as a cross join here. Okay, cross join.
So it will have every attribute of both tables.
Yes. So cross join is basically Cartesian product only, right? Cartesian product, we can say. So let's say for example,
I have a doubt. If there is 2 common, then we will not perform the natural join. No?
yeah. So generally we don't perform natural join while writing the query. But if in the exam, if we ask the question, we have 2 tables and in that both 2 columns are there, common columns are there, then you have to check for the combination of both the columns there. Okay, like that.
Sir, in cross join also we are putting the condition, sir, after where means
Yeah.
from player table this and like that where we'll put and what is the joining with the common attribute we'll put and condition we'll put. No, then how comes here no common attribute
No.
as
Here
cross
we are
join?
specifying the condition. It means what? We are filtering the output. We are filtering the output here, right?
The above cross join no common attributes, then it will act like a cross join
Yeah, cross
in
join.
that thing. I was
Yeah. So let me take this example here. So let's say, for example, here we have players and point, right? So if I perform players natural join points here, okay? Players natural join points. So here, based on the common attributes, automatically you can say player ID, only one thing is there. So we are going to match based on this. Let's say, for example, so in that case, it will work as a inner join. Inner join means we are going to get the 4 number of rows in the output. Okay. Now, let's say, for example, instead of player underscore ID, I am just putting here player ID only without underscore. Even though the value will match, but here column name should get matched, right? That's why we are saying based on the common attribute, or we can say common column name here. So here we have underscore ID, here we have player ID, and we don't have anything common in both the tables. In that case, it will work as a cross join. So here I have 6 rows, here I have 4 rows. So in the cross join, we are going to get 24 rows here. So combination of this row with all the 4 rows here. Are you getting my point? What we are going to get in the output?
Yes, sir.
Yeah.
Yes,
So
sir.
there will be 6 columns: player ID, name, jersey, match ID, score, player ID, and for this there will be one row. For this row, there will be 4 combinations like that. So in this way, we are going to get 24 rows in the output. Okay. So if there is no common attribute, it will act as a cross join here. Okay. And if we you are saying about the where condition, where is basically filtering clause here. Once we get the Cartesian product, then we are filtering the output here. Okay. But in the case of natural join, we cannot we are not filtering, right? Anything, we are simply saying natural join points like that. Okay. Okay. Great. Now let's say, for example, here we have match ID. Instead of match ID, I am saying it's a jersey underscore number. Okay. So this is basically, yeah, correct. Now tell me, if I perform the natural join, what will happen here?
No.
How many rows in the output? No output, 0 rows. Yes, anyone? So this is basically natural join symbol
Sir,
in
3
relational
rows.
algebra.
Error.
Sir,
3 rows. Which one?
sir, 10, 6, and 9.
Mm-hmm.
They are
No.
not matching one player ID.
So we are matching based on both the things here, right? So here we are saying player ID, jersey number, and here also we have jersey number, player ID. So here we have 2 attributes in common, and now we are performing natural join. So it will join based,
Zero, sir,
yeah,
can't be connected.
yeah, it will join based on the combination of this one. So do we have 1 9? So 1 10 is there, 1 9 we don't have, 3 9 no. We don't have any common here. So here it is basically 4 6, and here we have 6 4, right? So again, yeah, 6 4. So this is here we are going to empty a set here. But let's say, for example, here I have 9. Okay. Now you can see this 3 9, player ID is 3, jersey number is 3. Here also player ID is 3, jersey number is a 9 here. So in that case, we are going to get this row as output. Okay. Entire row. This row along with this row. Okay. So we have to match based on both the common columns here. So how many column we are going to get in the output? Yes, anyone? In this case,
4.
4 columns. Player ID, name, jersey number, but already jersey number, player ID is there, and then both one will be scored. The output will be 3, Lewis, 9, and 166 in the output. Okay. Anyone, any doubt here what we have discussed?
No,
Sir, I
sir.
didn't got no, sir. I didn't got the point of natural join.
In the case of what?
The last one you said 4 rows is
Okay.
player ID, name, and jersey number.
Not 4 rows, 4 columns. So let's say, for example, instead of this match ID, here we have a jersey underscore number. So in this case, we have 2 common attribute you can see. And if we perform the natural join between both the tables, so first it will try to match the based on the combination of player ID and jersey number. So in this case, we don't have any matching combination, so we are going to get a zero, empty row in the output. Let's say, for example, I am just doing one change here. Instead of 10, we have 9. Now, in this case, if you observe player ID 3, jersey number 9. So we have combination of 3 and 9. Do we have that combination here in this table? Yes, you can see this 3 and 9. Then based on the matching criteria, that is basically players from players dot player ID equals to points dot player ID and jersey number equals to this jersey number. So we are going to get this row in the output. Okay. So this row in the output, and the output we have 4 rows, that is 4 columns, that is player ID, name, jersey number, and we already covered this one, so we left with score here. Okay, because these two are common in both the table. And now we are going to
we will be getting one row, no?
Yeah, only one row. Yeah, sorry.
Yeah, that was the confusion.
So row is 9 and score is 166. So only one row, 4 columns here, like that. Okay, in the okay, great. So here we have discussed about cross join, natural join, and then simple we have inner join. Okay, so like what we have discussed, it will work in similar manner, inner join. Okay, so if I just update this to even though we can simply just write join, or we can use inner join as well. So both things are fine. Okay. So in this case, we are going to join based on the condition here, on clause here. You can see on clause is this one. So based on that, you can see we are going to get 4 rows in the output. Okay. Simple inner join. But we have other things also, that is using. Okay. Select star from, let's say for example, players inner join points, and we are not specifying this on clause. In that case, we can go for using here. Using, and in bracket we have to put the common column here. That is basically a player ID. Okay. So this also a inner join only. But here instead of mentioning on clause, we are using the using a thing here. Right. In using, we have to put the bracket and we have to put the common column here. Okay. Yes, anyone, any doubt, any question in the case of inner join?
No, sir. And sir, you'll share the PDF, right?
Yes, yes, I will share.
Okay, sir.
Sir, that using thing I didn't understood, like using player ID.
Yeah. So we can perform the inner join in 2 ways. Either we can write this query here, inner join or simple join, and using on clause here. So on which attribute I want to join. So players dot player ID equals to points dot player ID, right? But if I don't want to put on clause here, I can also use using here instead of this condition, right? So automatically it will perform the inner join based on the player underscore ID. So it will try to match player ID from players table with the points table player ID here. Okay, instead of this one, we are using this using keyword here.
So sir, using the word using player ID will reduce the time complexity like that, or it will be the same. I mean,
No, it
both
will
the
be the same only in the case of this inner join, but we can use this only if the column name is same. What if we have a player ID here? In that case, we cannot go for a using a thing here, because we want to join based on these 2 columns here, but the column name is not same. Okay, so for this keyword, column name must be same. Now here we can perform players dot player underscore ID equals to points dot player ID only. That's it. Okay.
Okay, so for using the word using, we need both the column names to be exactly same.
Yes. Yes.
Okay,
Yeah.
sir.
Okay. So if you look at the FLIS schema, right? So we have their match table. In that we have referee ID, and in other table we have referee, then assistant referee 1, assistant referee 2, like that. In that case, we cannot go for a using, even though we know that the same values are being used here, not for jersey number of player ID, right? but we cannot use using because the column name is different there. Okay, so we have to go with the on clause only. Okay, great. This is about different types of joins we have, and do we have any other? Okay, so let's try to solve this question. If you understand how right outer join works, so tell me here. And yeah, I guess we have asked this question in quiz 2. Tell me the number of rows. Oh, sorry, here we want difference. So tell me the maximum number of rows first. Maximum, and then we want minimum here. Tell me maximum number of rows and minimum number of rows. First, tell me how many maximum number of rows we are going to get. We have these three tables. Employees having 100 rows. Designation is having 6 rows, and this is having 5 rows. And we are performing what? Right outer join, and this is basically a right table here based on the ID. So employee ID, designation ID, you can see like that. Tell me how many maximum number of rows we are going to get.
Is it 106?
106.
Maximum will be 90.
106.
Be 0.
Maximum will be 105.
5. Yeah.
What will be minimum?
100.
Minimum 100. Okay, we'll see. So first, let's discuss about maximum here. So we have this schema, right? So we have not mentioned any constraint here, right? So how right outer join works? So this is basically a right table. Here we have 6 rows, and here we have 100 rows. Here designation ID is basically what? Primary key, and we are performing join based on this. It means what? All the 6 rows will have unique ID here, right? D1, D2, D3, D4, D5, D6, like that, right? But this is taking reference here, right? Employee table is basically taking reference from this ID. So here we can see a foreign key here, right? Now, if I want maximum number of rows, right? Maximum number of rows, what will be the condition or what will be the scenario here? Yes, anyone? In which case we are going to get maximum number of rows?
One of the
All
designation
employees.
will match all employees.
Yes.
Okay. So here we have mentioned we have not put any criteria here. Okay. In that case, so if I say designation ID, this can be what? This can be null also, right? If this is null, then how many rows will be there maximum? Sorry, if this is, sorry, we have one maximum, right? Yeah. So if you want maximum, it means what? If I just consider even one ID here, let's say for example D1 100 times, this is possible, right? In this table, employees table. In that case, how many rows we are going to get? First, based on the matching criteria, that is basically what? 100 rows will match with D1. Then remaining rows from the right table, that is this table. So remaining rows will be this 5-1. So we are going to get 105 maximum number of rows here. Okay. Anyway, any doubt in the case of maximum number of rows?
Sir, I didn't got like how this maximum rows got.
Okay, so here we have 6 rows, right? It means what? All the ID will be unique here because it is a primary key. So here we have D1, D2, D3, D4, D5, D6 like that. But this is taking reference here. This attribute is basically a foreign key here for employees stable, right? It is taking reference from this one. It means what? If we want the maximum number of rows, so in which scenario we are going to get maximum number of rows? So this can take the values from these 6 values only. It cannot take any other value. Okay. So let's say for example, if all the 100 rows are basically D1 only, in that case only we are going to get 102 rows. Okay. But let's say for example, we are going to get D1 first 50 rows and let's say D2 the next 50 rows. In that case, 50 rows will get matched with this D1, 50 rows will get matched with this D2, that will be 100, and remaining will be this 4 one. So we are going to get 104 rows. But we want to find out maximum. There is only criteria where ID will be any one ID. It can be D1, D2, D3, but all IDs will be same here in the employees table of all 100 rows. In that case, only we are going to get the maximum number of rows here, right? So all 100 ID will be same here.
Okay, so the all 100 IDs will be same. We have to assume that thing
Yes.
for maximum. Okay,
Yeah.
so got it. Thank you.
And then all 100 will try to match with this one only, with any one of this, right? Whatever the ID we are going to use here. And the remaining will be added in the output because we are using right auto join here. That's it. Now what will be the case in the case of minimum? Yes, anyone?
6, sir.
Minimum 6.
So here we have not mentioned about any condition. If you look at some previous year question, we have added a note here. Okay, but here that note is missing. If we put note, then answer will be different. Okay, so here we don't have put any condition here. It means what? It can take null values also. If it can take null values, it means there is no matching rows in both the table. So we are not going to get any rows here. Then it will return remaining rows from the right table. That is basically 6 1. So minimum will be a 6 here. Okay, and the difference will be of 99, like that. Okay, but if I put a note here, all attributes are having not null constraint. Okay, in some, if you see some previous year question, we have this note. In that case, what will be the answer of minimum?
5.
5.
100.
Yes. In that case, 100 will be the answer. Okay. So here I cannot have a null value here. So in which case we have to think we are going to get minimum number of rows in the output. So when all the 6 value will be part of this ID, in that case we are going to get 100 rows. Okay. So this is basically for a case without constraint, without not null. And minimum will be 100 in the case of with not null constraint. Okay. Okay.
Sir, can you explain this again? Like with and without not null. I didn't get it.
So we want to find out minimum number of rows here. So first, let's say for example, without constraint. So it means what? We can take all the null values here. So all 100 will be null, null, null. It means what? There is no matching rows in the table employee for this ID. So we are going to get 0 rows for matching, and then the remaining rows from the right table. That is basically 6 rows we have. So that is basically minimum 6 number of rows, because all the values of employee table will be null for this ID here. So it will not match with any one of the rows. So that's why it will give us 6. But if I put a constraint here that we have not null constraint, it means what? We cannot put any value null here. There must be some value for this particular column, and that value must be a part of this 6 ID here only. So if all the 6 IDs part of 100 table, let's say for example D1 is there like that 20 times, D2 is there 30 times, D3 is there 10 times, D4 is there 40 times, D5 is there, let's say 5 times, and D6 is also 5 times. So together we have 100 times. So in that case, it will try to match with this one ID only. So we are going to get 100 rows only. Okay. Anyone, any doubt here how we got 100? So just consider the scenario where all the IDs are part of this ID here. Okay. In that case, we are going to get 100 rows only, because there will be no row left in the right table here. Okay. Is this fine? Any doubt now?
No, sir, thank you.
No, sir.
Great. So we have discussed about the joins in SQL. Okay. Great. So please do watch the session on OP sessions or even quiz 1 session, revision session. So we have discussed this one. So you can expect a question based on the SQL query. Try to find out output of this query, like that type of question you can expect. Okay. or based on the joins here, concept of joins, or based on the data types and constraint like what we have discussed. Okay, good. This is about week 2, week 3 here. Now, week 4 is basically what? Relation algebra, TRC and DRC. TRC, TRC, and then we have ER diagram part. Okay. So for ER diagram part, just refer to the tutorials. That is good enough. Okay. So we have around 3 to 4 tutorials. So please watch all the tutorials. So that is good enough for ER diagram exam. Okay. So which symbol is used for which scenario, you have to you should know that, and how many tables are required for that ER diagram, that also you should know. Okay, so we'll revise that also, but before that, let's discuss about relational algebra here.
Sir, those tutorials for ER diagram are on YouTube channel of DBMS.
So on the portal only.
Portal,
just
okay.
Go to week 4 section. We have.
Okay, thank
So
you.
here we have relational algebra. So we use mostly 3-4 symbols. First one is basically a pi. This is basically a projection here. So we are projecting some attribute from the table here. Then we have sigma, that is basically a selection. Okay. So projection is basically equivalent to a select in SQL. Selection is basically a filtering the rows, that is basically a where clause. Then we use this row symbol for renaming the table here. Okay. And then we mostly deal with this projection, selection, this row, and these two things. Okay. So here cross is basically a cross join, and this symbol is basically a natural join. Okay. We have something called theta join as well. Okay. So theta is basically a condition for joining. Okay. So basically it is equivalent to cross join with some condition, that is basically theta join. That's it. Okay. So you should know this 4-5 symbols. That's it. Okay. We are not discussing in detail. Okay. But other things is basically what? Set operators. So if you look at the relational algebra or even TRC, DRC or even SQL part, the output of SQL query is basically a set. So we can perform various set operations between the output of SQL query, relational algebra, TRC, DRC only, right? So you should know all the set operators. This is basically a union, this intersect, and minus is basically difference. So here we have union, basically intersect, and here we have a difference. Okay. But if you look at the projection here, so let's draw a table. Here we have relation R, we have A, B, C. Okay, and let's say for example here we have 4 columns like this. So A1, A1, A2, B1, B2, B3, C1, C2, C3, like that. Okay. Now if I say project A from relation R here, okay, so what will be the output? How many rows we are going to get?
3 rows.
3.
So 2 rows.
2 rows. So projection will give us distinct values only. Distinct values. Remember, okay? Unique values we can say. So projection will always give us the unique values. So basically it is equivalent to a select a distinct here. Okay. Now if I say pi A comma B, then R, how many rows now?
3.
Because here we have 2 attributes. It will go for a combination of both attribute here. So this combination is unique here. If I have B1 here, in that case only 2 will be there. A1 B1 and A2 B2. Sorry, A2 B3. Okay. But here we have B2. So in this case we are going to get 3 rows in the output. Here we are going to get 2 rows in the output. Okay. This is about the projections. We are projecting a particular columns here. That is what projection is. It is equivalent to select distinct in SQL. Then we have selection. So if I say pi A, then we have to put this sigma operator, and here we have to put the condition C equals to C2 That's it. And then we have this relation R. It means what? Select distinct A from this R where C equals to C2. So we are going to get A1 in the output. The output will be A1 here. Okay. So basically it is equivalent to a where condition only. Okay. Where condition. That's it. So we are filtering the output here. That's it. Now here we have rename operator. So let's say for example, I want to rename this one. Okay. So let's say I have two tables here. Let's say a student table and the course table. Okay. So I want to perform the natural join here based on, let's say for example, roll number column. Okay. So here project, let's say for example, name, course, I want name and course. Here sigma. Now what we have to do, we have to put the condition student dot roll number must be equals to course dot roll number. So we have to write student then dot and equals to course like that. But if you want to just use the alias here, so we can use a rename operator here. So I can put yes dot roll number equals to a c dot roll number instead of writing entire table name, but here I have to use the row symbol here. Okay, so this is basically what a row s, and that is basically a student. Let me write it here. Okay, so that will be here. So row s, and this is basically a student. Okay, then we are performing cross join. Row C, it will be a course like that. Okay, so instead of student, we are going to use yes now. Instead of course, we are going to use C now. That is what it is saying here. So we are renaming the column name here like that. We can rename the column name as well as a table name here using the renaming operator. This is cross join. So how cross join works, you know, this is about natural join here. Anyone, any doubt what we have discussed?
Sir, in select, we can do AND operator.
Select here.
Yeah, like project A, where you select A equal to A1 and B equal to B1 of R.
Yeah, so in the sigma operator selection, we can use AND operator. This is basically AND, this is basically OR. Okay, so we can use this AND and OR operator in the condition here. You can see this question here. Let's discuss this question. Now let's read the question and tell me which one is correct here. So whatever we want to select, that is basically projection here. So if you say I want author IDs, so I am projecting author IDs in all the four options. Okay, tell me which one is correct, then we'll discuss this one.
Sir, option 2.
Yes, sir. B.
Okay,
It's correct.
So we need to find out what are author IDs of those authors who have written both the books. Okay, books of both science fiction and fantasy. Okay, now this will be based on this genre you can see here. Now what issue with option number A? Is this correct or what? Yes, anyone? So first we are projecting the author IDs of authors who have written author ID, and we want author ID and a condition on this one. So we just need to use author ID here, but we cannot use author, we cannot match directly here. So we have to match with the book and rights. So yeah, we have to use book and right table here. This is correct. So we are performing natural join in book and rights. So we are applying a condition based on this one, so science fiction, and we are projecting author ID. So this will give us what authors who have written the book based on the science fiction here. What about this one? Author ID written of the authors who have written the book fantasy, right? Generally fantasy here. And now we're taking intersection of that. So are we going to get the IDs of authors who have written both the books here? In this case, option number 1.
No, sir.
Yes, sir.
Yes.
Yes. Okay. So let's say, for example, we have author ID 1, 2, 3, 4. They have written this science fiction book, and here we have 2, 5, 7, they have written this fantasy genre book. So if I take an intersection of that, I am going to get this A2 and A1 in the output. So author who have written both the books here, right? So option A
We
is
are
correct
not using author relation.
because it is not required here. We just want author ID so that we are going to get from the rights table, and we want to apply condition based on the genre, so we are going to use book table here. So we have to join these two tables. That's it. Okay. So even we can join this table, but it is not required. Okay. What about option number B? Is this correct?
Yes, sir, because we're taking and in the genre where.
See, here we are performing AND operation, right? So let's say, for example, genre, and here we have author ID. Okay, we have performed join. Let's say, assume we have performed join. We got these two rows. So here we have A1. Genre is basically a science fiction here. Now, how we can apply two conditions on the same row here? Whether genre is science fiction as well as the fantasy? No, right? So we cannot apply a AND clause on the same attribute here like that, because in the same row it cannot satisfy two values at the same time, two conditions at the same time, right?
Okay.
It can be
Could you please repeat
genre
this
can be
one?
science fiction or fantasy or anyone, right? If we want all things here, that is correct. If I use or here, and if I say I want to find out author IDs of those who have written both the books, not both the books, who have written the books either fiction or fantasy, in that case, this will be a correct. We can use or, and we can use union also in that case. If I want science fiction or a fantasy, okay, in that case, option B and C both will be correct. But here we have to use intersection here. I cannot apply, I cannot check two conditions for the same row here, right? Either genre can be a science fiction, then it will project, but again, and genre can be fantasy. No, both conditions will not satisfy here. Or it will
Okay.
satisfy. Genre is science fiction or a fantasy, yes, or will satisfy here, not the and. Okay.
So we can use or with
Hello?
where, but
Yeah.
not and.
No.
Okay, sir.
Here means what? Because we're applying a
Hello?
condition on same attribute here. Okay. Yes.
Sir, if
Sir, it is acting like a subclause,
it is
sir,
correct,
first one.
Sorry, which is correct? Can you repeat?
sir, if attribute different, then it is
Yeah, if attribute
correct,
names
sir?
are different, then we can use and clause here. Sigma genre equals to science fiction, and let's say, for example, title equals to something, right? DBMS, we can perform if attribute names are different, because it will try to match with the attribute here. If genre equals science fiction, yes, and title equals to this one, then we can do that. Okay? But for the same attribute, it cannot check both the condition, because it cannot be true at the same time. Okay, we can use or condition. So option A is correct, not option number B. Sorry, option A is correct, not B. C will give us union. It means what? Written science fiction or fantasy book. In that case, option C will be correct. Option D is anyway not correct. Again, same reason here. Okay. Anyone, any doubt in this question? So
Sir,
remember,
first
we can.
option is acting like a subclause, sir. Like we are extracting from a science fraction, then other, and then taking the intersection from both, like a subclause.
No, we cannot say like that. This is a different expression here. We're taking a different expression here, and then we're performing the intersection. Okay. So
It's
it's
like
like that.
subclause only, no, sir. That is like subclause.
Sir, does the
Subclause.
intersection works like and statement?
No. So, and it's a different thing. And it's basically conjunction, we can say. Intersection is basically set operators. Right?
But what exactly it means? Like genre is the science fiction, and as well as the genre can be fantasy.
Yes. So there can be author who have written both the types of books, right? Let's say, for example, author one is there. We have written a science fiction as well. So So in the same book, you can see we have a book ID. So here we have book ID, here we have title, here we have gender, right? So A1 has written some book, let's say for example science fiction, and A2 has written some book, let's say for example science fiction, and again A1 can write a different book with a different title based on the fantasy here, right? This is possible because we are, sorry, book ID is there. So this is basically a different book ID, B1, B2, B3. But if you look at the rights table here, we have this underline. Underline means what? Yes, anyone?
It's
What
a
is
key.
Key.
Primary key.
it's basically a primary key. So combination of book ID and author ID is primary key. It means what? B1 A1 is possible. B3 A1 is also possible, right? Combination is unique here. So author has written both the books here, like that you can see. Okay. Okay. Great. So always remember the output of any SQL query or algebra or TRC, DRC, it will be a set only. We can only perform the set operations here.
Sir,
Okay.
I have
Even
a
if you
doubt.
just select something, union, select something we can do. Yes.
Sir, if in the question it's written that author has written science fiction or fantasy genre, then will option 3 be correct?
This option C will be correct. Yes.
Okay, sir.
And if I just change this to or, option B will also be correct.
Okay,
Okay.
sir. Thank you.
Okay. So this is about relational algebra. So remember, important thing, it will always give us the projection will always give us the distinct values. And rest is just you should know it is equivalent to SQL query, how we can get the output. That's it. Okay. Now this is basically a question. TRC, DRC here. Everything we have covered in this question. Right?
Yes, sir. I actually don't understand questions of TRC and DRC.
Yeah. Okay. So you can refer to a tutorial in week 3. I have a tutorial on TRC. You can just refer to that. Okay. I have explained that. So
Okay.
let me take one example here. Okay. TRC first here. Right. So let's say for example here we have a student table. Okay. We have a name, then we have age. Here we have roll number. Let's say for example. Okay. And we have few data here like that. Right. Now my query is in relational algebra. Select name, sigma, age greater than 21 from the student table here. Okay. This is what my relation query is. Relational algebra expression is. Now I want to write a TRC expression for this. Okay. Which is basically equivalent to what? Select distinct name from student where age greater than 21 like that. Okay. So same thing. Now, in the case of TRC, we generally represent this curly bracket. Okay, this curly braces is there, and here we have vertical line, right? Midline we can say, and here we are putting a variable. Okay, a tuple variable we can put t, we can put any variable here. Let's say for example, let's say t only. Okay, now we have to use this table. So we are defining that there exists yes belong to student. Now S is basically a student table such that there's some condition getting satisfied here. Means what? Age is basically what? Greater than 21. Now age belongs to student table, so we have to mention S dot age greater than 21 in the bracket. But if you see here, we have just this T here. There exists S belong to student such as age greater than 21, but I want to project the name as well. So how we can do that? Yes, anyone? So here we have to use AND clause T dot. Whatever the variable you have defined that you have to use. T dot name must be equals to S dot name here. So whatever the variable you are going to use, T, X, P, A, B, C, anything here, you have to use that one whatever the attribute you want to project here, name, roll number, anything here, so that you have to use t dot name, t dot age, or t dot roll number if you want to project this one. But this equals to what? From which table I want to project, that you have to specify here. From student table, it will be a name. From student table, it will be a age, or from different table, whatever the attribute we have to define like that. So here we are projecting this one. So t dot attribute equals to s dot attribute. It will give us that attribute from the student table here. Okay, projection here. Here we are applying the selection condition, or we can say selection here, sigma. Here we are performing projection. This is basically a relation here, we can say. And here we are using a tuple variable. Okay. So when this entire expression is true, then only we are going to project this particular tuple like that. This is one of the way of writing the TRC query. Okay, first tell me any doubt here? Okay, so this is another way of writing TRC query as well. If you look at a different reference book, but we are following this one only. Okay, so another way how we can write that, same thing, but instead of using this variable, we are directly specifying what s dot name here. So I want to project the name only, and rest everything will be same. Student, and in bracket we have to put s dot age greater than 21. That's it. Okay, so this is what it is required. But if I use a tuple variable here, you have to define like that. Otherwise, whatever attribute you want to put, you have to put it in before the this vertical slash here, vertical line here, like that. Okay. Okay.
So,
If you
sir,
understand
before
or
the
you don't,
vertical line, how many tuples can we use? I mean, 4, 5, or if we
any
want.
number of. If you are
Okay,
following
sir.
this structure, you can use s dot name, s dot age, roll number. You can do like that. Okay. But if you are following this one, so you have to use this tuple variable only. In condition, you have to put whatever the attribute you are projecting. Okay.
Okay, sir.
So we are following this in our course. So first, tell me, we have this relation here. What about this one? What this will project? What this will give us? Yes, anyone in terms of statement? What we are doing here?
So we are projecting the auto. So we are
Yes.
projecting the auto parts name, where the auto supplier's location is Mumbai, and in the catalog its price is 5,000.
Hmm. Yes. So here we are using x as our tuple variable, and you can see here x dot sid equals to c dot sid. It means what? Also we have x dot p name equals to p dot p name. So we are projecting two variables here. SID from the catalog table here, this one, and name from the product name from the auto parts here. Okay, this one. So we are projecting SID and P name, right? Based on which condition? Based on the condition, you can see location must be Mumbai, price must be 500. So this is basically a condition. This is basically a projection. What is this? Yes, anyone?
So table joining.
Yeah, this is basically a joining condition. Okay, so you can see this filtering condition. This is basically joining condition. Here we are projecting that, and here we are doing the, we are using the three tables here like that. Okay, and then we are using X here. So this will give us what? SID and part name whose supplier's location is Mumbai and price is 5,000 like that. Okay. Anyone, any question here? How we are getting this? Is this clear?
One time repeat, sir.
Okay. So here if we got this TRC, so how we can identify TRC? Here we have this curly bracket, and we are using this vertical slash, and we are using this variable here. In the case of DRC, we use angular bracket. Angular bracket means DRC here. Okay. Now see, we are using a tuple variable X. We have three tables. So there exists S belong to auto supplier. S means auto supplier. There exists C belong to catalog. There exists P belong to auto parts. Now we have these three tables, right? We have used the three tables. Now we are applying a condition where location equals to Mumbai, price is equals to 5,000, and x dot id you can see here. It means what? We are projecting the SID from C table, that is basically catalog table. We are projecting a P name from the P table, that is auto part table here. So we are projecting SID and P name from this output of these three joins. But how we are joining this three table? Based on this condition here. You can see S.SID must be equals to C.SID and P.PID must be equals to C.PID. So joining condition we have specified. Filtering condition here we have specified. What we want to project here we have specified. Okay. Okay. Now what's the difference between first and fourth expression? Yes, anyone?
Here we are only selecting the SIDs, not the names.
Okay, I think one table is missing. Yeah.
One
Sir,
table also.
we are also
One
not
table
joining
we have
auto
missed.
parts EID.
SID and CID, supplier, suppliers and catalog. We are joining suppliers and catalog. But we want name also, so that we are going to get from auto part. So we are not using auto part table here.
So we are not using PID for joining to get the P name.
What we are projecting here, we are projecting only SID here. Yeah. So that entire table is missing. Auto part table is missing here. You can see. We just are using two tables. Okay. So here we are projecting SID from the catalog table where location is Mumbai and price is basically 500. We are just projecting SID here. That's it. Okay. Not the product name. Now this is about the TRC here. Now what about a DRC here? So see again, name, age, let's say for example roll number here. Okay. So in the case of DRC we use this angular bracket. Again curly braces is there. Then we have vertical slash, but here we are using angular bracket. Now here we are specifying whichever attribute we want to project. But here we are not using tuple variable. Here we are using domain variable that is basically based on the domain, that is basically column here. Okay. So whatever you can see here, let's for example I am saying this A, this B and C. Now I want to project the name here, but I don't have to use name here. I have to use this domain variable B. So here I am projecting a B here. Right. Now how to write the expression here, because we should know what this B means, right? So here you can see, okay, so there exists, we can use variable A comma B comma C, right? Like that. Student, sorry, not student. In angular bracket we have to define what is ABC. So ABC A comma B comma C belong to student. So here we are defining that A comma B comma C, this belong to student. Now you have to consider same order of the schema here. It means what? If A is given first, so this will be A, this will be B, this will be C. Okay, like that. If I just mention B comma C comma A, so this will be B, this will be C, this will be A. If I want to project name, then I have to use C here instead of B, like that. So you have to refer to this first. How we have defined the domain variable for that particular table, that we have to stick. And whatever you want to project, so that variable we have to use here. If you want multiple variables, let's say for example name and age, so we can simply put C comma A in angular bracket, that's it. Okay. If you just want one variable, you can just put one variable there, like that. But we want some condition also, so here we have to put one condition. And now age, now I am not going to write age here because we are dealing with domain here. Age is basically A here, so I'm going to write age greater than 21, so A greater than 21, that's it. So instead of writing the column name here, we are using a domain variable. How we are defining that, you have to look for this particular thing here. Okay, so this is about the DRC part. We'll see with the help of example.
Sir, I have a doubt.
Yes.
Sorry, in the above, after for every ABC and in angular brackets, why we haven't consisted the order like for every ABC in angular brackets, ABC belongs to student.
Yeah, so here we can use any order. So I have just used B comma C comma A. You can also use A, B, C. So you have to do changes accordingly like that. You have to consider.
So we don't need order based on the for ABC.
No, whatever is defined here in the DRC part, that you have to consider. Okay.
Okay, sir.
So if you see here, here you can say, is this visible? DRC option number A.
Yes, sir.
Yeah. So you can see here DRC. We are projecting yum. What is yum? I don't know. So I will refer to this one yum comma n comma no. Uh, O belongs to what? Autopass. It means what? M refers to autopart table. Now what is yum here? You can see we have autoparts. Now we have to consider same order here. So this will be
PID.
autopart. Yeah. Yum n o. So we are projecting PID here. So we are projecting PID here from auto parts. What's the condition? N equals to suspension here. Now what is N here? You can see that is a part name. Part name is suspension here, right? That's it. Then we have and there exists ABC. Now what is ABC? Again, I have to refer to this one. Now this ABC belongs to catalog. Now ABC belongs to catalog. Now C equals to 500, 5,000. What is C price here? So we have mentioning like this. And what about this one? Yes, anyone tell me what is yum equals to A?
PID
Sir,
of auto part is
autopart
same as
PID.
PID of catalog.
So joining condition, right? This is basically a joining condition for that table here. Okay. Now, if you understand this, tell me which option is correct for the first one here, TRC. Here we are projecting SID and P name. We are using all the three tables here based on the Mumbai and 5,000 price here. Now tell me which option is correct here. So we are dealing with Mumbai and 5,000 price here. So anyway, suspension option will not be.
Sir, option E.
Yeah. So here we have this one G
Option
A
E.
E. Okay. Why not B?
Because here only select the P value.
Yes. Anyway, option B and C not correct. Go for E and G. We have left with two options now. So here we have P comma N. But what is P? What is N? I don't know. Here you can see M and O auto parts. N belongs to what? P name here. So we are projecting a P name. Now here PQR. PQR belongs to what? A supplier. Now what is a P here? SID. So we are projecting SID and part name. That is correct. Then location is Mumbai. R should be Mumbai. So location is basically R here. That is correct. And we have ABC belongs to catalog. C is basically price. And what is this one? M equals to A and P equals to B. So we are joining both the tables here. Yes, that is correct. So 1E will be a correct here. What about G? Is this correct?
Sir, in G there is no joining.
Joining. So
If there is no joining, it means what? It will act as a cross product. So we are performing a cross product here and then we are applying this condition. But we are not going to get the required output here in the case of a cross product. So G is not correct here. So 1E is correct. Now check for second one. What we are projecting, which table we are joining, on which table attribute we are putting a condition, how we are joining, you have to check that and then try to match with the DRC query. So what we are projecting here, yes, anyone?
the ID.
Sir, auto parts ID.
Auto parts and ID. So X belongs to what? So we'll see where is X. X is basically this one. So we are projecting only PID, that is basically from P table, and P is basically what? Auto part. So we are projecting PID here. Okay. Yes, but based on the condition, Product name must be suspension and the price must be what? 5,000. So we are using joining these two table. We are projecting PID based on these two conditions. Okay. Now tell me which one is correct. This is gone. This is also gone. So just check
Sir,
for
option B.
B. Uh, B. Okay, let's see. But now condition is basically suspension. Now here it is Mumbai, right? Not. Check for this one or this one or this one. Not B.
F, I guess.
F. No, here we are projecting two attributes. What we want, just one attribute. So you can go in that manner. You can
A,
element.
sir.
Sir, D can go.
Okay, let's check with option number A first. So what we are projecting here, yum. And what we want, let's say what is yum here, auto parts. PID is correct, yes. Suspension condition is satisfied. Price is basically 5,000 and we are joining both the tables here. That's it, right? So we are getting all the requirements satisfied here. Is this correct? 2A? You can see we are projecting the yum, will basically PID. So we want that based on the condition of parts name, that is suspension. We have applied that. Then we have joined with the analog table. So we have done that here. Yum equals to A based on the condition. Also we have applied. So everything is correct. We are going to get this output. That is basically a PID for this required condition here. So 2A is basically correct here.
Sir, what's the difference between option A and D? I'm
Yeah, A and D here basically what? So projecting M correct, suspension is also correct, but here we are not using the there existing here, right? There exist here. Okay, so we have to use there exist attributes. Now see here I am applying condition on N and I am projecting M. So I am using two attributes from the auto parts here in the query. So I have to mention there exists M comma N. This O is basically optional. Okay, I can remove this as well. Doesn't matter, but I can put that as well. So what we are saying, there exists M and N such that N is basically equals to suspension. Okay, this is what we are saying. So there exists is missing in option number D here. You can see.
so in DRC it's important to write for exist
Yes,
option.
there exists. Yeah.
Okay, sir.
So
Thank you.
there exists this attribute such that attribute equals to this one. This is what we are saying, right? Otherwise, we are simply renaming the table, but we are not specifying the condition here. So entire thing is predicate here, predicate logic, right? So there exists this attribute such that it is equal to this one. And here I don't require O anywhere, so I can skip this part. Okay. So we have to use there exists yum n. So which of the attribute we are using in the query that you have to specify in there exists symbol. Same thing in the case of ABC. Here we are just using C and A, not B. So I can skip B part here. Okay, but better to mention A comma C like that. Okay, like. So I hope you understand the concept of TRC and DRC. Rest you can try to solve. Okay, this 3 and 4 here. So rest is just simply what we have done. So here again we are projecting same thing, suspension, but here we are projecting along with the PID S name also, and we are joining one more table. That's it. So you can see
Sir, answer is 2. Option 2.
option D is correct here. Yes. Okay. So 1E, 2A, and 3F will be for this one because we are projecting two attributes here like that. So try to solve this question. I will share. Okay. But anyone any doubt in TRC and DRC?
No, sir.
Okay. Great. Now then we have relational algebra here. So we have discussed relational algebra. Now remaining is what? ER diagram. Okay. So you should Now about ER diagram, which symbol is used for which purpose, right? So let me check that also. Just a second. Supplementary content. So you can go to the portal supplementary content inside the slides folder. Here we have revision slides, okay, for quiz 2. Quiz 2. Should be which one where it is. Let me check.
Sir, under supplementary contents, where do you told?
Slides, lecture slides, right? So
Okay.
let me share with that link with that I'm prepared from here. So you can see here revision slides for quiz 1. In that we have the summary slides. So for week 1, just go through the summary slides. These 4-5 slides are there. This is good enough, okay? Then for week 4, like we have discussed TRC, DRC, please watch the tutorials. You can see this expression, right? So same slides I have used in the tutorial, so you can refer to this one, right? And then ER diagram. Yeah, this slide is very, very important. So which symbol is used for which purpose? You should know. So kindly go through the slides of ER diagram and week 1 here, okay, of this particular revision slides. Okay. Now let's say, for example, I have this one. So let's say E1, E2, R1. How many tables are required here? Minimum number of tables are required. For the case 1, yes, anyone? Yes. In case 1, how many tables are required if you want to represent this ER diagram into a relational schema?
3, sir.
Yeah, here we have many to many, right? So E1 will be there, E2 will be there, and R1 will be there, in which the primary key of E1 and E2 will be a key here, right? So primary key of E1, primary key of E2 will be a key of R1, and if R1 is having any attribute, that will be a part of this R1, and this respective attribute will be part of the E1. That's it. That's in the case of many to many. What about many to one? Either arrow in this side or this side. In this case,
2, sir.
yeah, in this case, 2 tables are required, just E1 and E2. That's it. Okay. And here we have to see based on the requirement, 2 tables are required. Only 1 table is required. Yeah. So here 2 tables are required. Okay. We don't require for R1. E1 will consist of all the attribute it has, and E2 will consist of all the attribute it has. But in the case of E1, we can add the key of E2 here. Okay. So in either one of the table, there will be a E1, E2 a key here. That will be a many to one here. So this thing we have discussed in detail in tutorial. Okay. So please watch tutorial. Around half an hour to video is there. So in that you can see which diagram is given, how many tables are required, okay, and what is the schema for that. So please go to the tutorials. That is good enough for this one. Otherwise, it will take again 1 hour to explain this one. So please go to the tutorial. We have discussed that in detail. Okay. So from ER diagram, just remember this slide and this slide, like anyway, this relationship. But how many tables are required for which scenario, that we have covered in tutorial. So please go through that. Okay. That's it. Okay, this is about ER diagram and the schema. Now, very important part, that is week 5, week 6. Okay, so normalization, very very important. Again, you can expect a very good weightage 10 to 15 or even 20 marks on this 2 weeks. Okay. Now, first we have discussed about the functional dependency. I hope everyone is aware about what is functional dependency. If I say A determine B, what does this mean? Yes, anyone? What is A determine B?
A uniquely determines B.
So A uniquely determines a B. So if in the table, if I have this two column, so A1 will be B1, A2 will be B2. Again, if I use A1, so that should be a B1 only. So A1 uniquely defines B1, like that we can say.
So all rows of A uniquely defines all rows of B.
Yes, we can say. But reverse is not true. B1, A1, B1, like we can also have A3 having value B1. This is also fine. So A uniquely determines B here, like that. Okay.
But sir, A1 cannot have B1 and B2.
No, no.
Right?
So A1, that is, we are saying A uniquely determines B, like that. So A1 uniquely determines B1 only. Right? So for example, your roll number determines name, right? So one roll number cannot have a two name like that. Okay. So that is the functional dependency. Then we have discussed about what? Candidate key, super key. What is candidate key? We have discussed about how to find out the closure of an attribute. Closure of an attribute. So please do watch the quiz 2 session. We have discussed this thing in detail. Yes, how to find out candidate key? Yes, anyone? What is candidate key?
Able to become primary columns which uniquely identify rows.
Yeah. So
minimal primary.
Minimal super key, that is basically candidate key. Okay. So candidate key is basically key which is used to uniquely identify the rows. Same definition of keys here, but it is basically a minimal super key. Okay. But how to find out? That's the main thing here. Okay. So let's say, for example, is this visible? This slide?
Yes.
So here we have a relation. We have this functional dependency like this. First, tell me what is the candidate key for R here? What is candidate key for R? How we can find out candidate key for R? Yes.
The
How we
AV.
approach? Okay. So tell me the approach. How you find out the candidate key?
Sir, firstly, we check which attribute is not on the right hand side of any functional dependency.
So always start with this one. First, check which attribute is not present on the right hand side of functional dependency. So E is present, D is present, A is present, C is also present, B is also present. So here all the attributes are present here. Okay. So in this case, we cannot go for that trick here. So the thing is, if any attribute is not part of the candidate key, if any attribute is not part of the functional dependency, that attribute must be a part of candidate key here. Okay. So we'll check with other questions here, but yeah. B, C, A, B, C, D. Yeah. Let's go with this one first. Okay. So by that logic, what we are saying, if any attribute is not a part of a functional dependency, means right hand side of any functional dependency, that must be a part of candidate key here. Any attribute are not part of right hand side of any functional dependency, then it must, we are saying must be a part of candidate key. It can be a candidate key or it can be a part of candidate key. Okay. So tell me here, which is not present? Which attribute is not present?
D and E.
Yeah. So if you see here, BC is present, A is present, G is present, F is present. D is not present on the right hand side of any functional dependency. So DE must be a part of candidate key. But before that, we have to check whether D is candidate key or not. How we can check?
So by closure.
Yeah. So if I take a closure of any key, so it should give me all the attributes of relation. Okay? All attributes of relation. Okay. Or we can say if I take a closure of any attribute or set of attribute, and if that closure is giving me all the attributes of that relation, it means it is a key here. So how we can check? First, take the closure of DE here. How we can take the closure of DE here? Yes, anyone? So first DE will consist of DE. After this, can we? Yeah. So from D, what we can determine? From
A.
D, I can get A here. Now
Then
see,
BC.
from D, from E, from A, or combination of any attribute, what we can get here? From A, I can get BC, right?
BC.
From E, I can get G as well. We have C and
F
we have
also.
D as well. From CD, I can get F as well. So are we getting all the attributes here of relation R? Yes.
Yes, sir.
So
Yes, sir.
DE is basically a prime candidate key here. That's it, right? If this is the thing, then D is basically candidate key. Only one candidate key is there. But let's say, for example, while taking a closure, F or let's say C is not a part of a closure here. In some questions, in that case, you have to go for DE and the attribute which is not present in the closure, DEC and DEF closure. Okay, then we have to check whether we are getting all the attributes of relation R or not. Then DEC and DEF will be a candidate key here. So first, always find out which attribute is not part of right hand side of any functional dependency. Then it must be part of candidate key. So you can see first we have to check whether it is a candidate key or not. This is how we can check here, and we got all the attributes here after taking closure. So D is candidate key here. But let's say, for example, in some question, few attributes are not a part of closure. In that case, we have to take the combination of DE or whatever the attribute we have with the remaining attribute, and then we have to take the closure here. Okay. So in that case, you can see we are going to get multiple candidate key here. Okay. Anyone, any doubt like what we have discussed, what I have said just right now? Is this
No,
clear?
sir.
Okay, great. So here we have a DE as a candidate key here. Now we want to find out number of prime attributes. Now what is prime attribute? What is non-prime attribute?
So prime attributes are the one which make the candidate key.
So DE is basically candidate key here. Now what is prime attribute and what is non-prime attribute?
D and E.
D and E.
Yeah, the attributes which are part of candidate key. Are prime attributes. So here you can see D gamma E. What is non-prime attribute?
Not a part of.
Yes, not part of candidate key. Simple. So you can see remaining all will be the non-prime attribute A, B, C, and then G, F like that. So very important step. If you look at the normalization question, we have to do this thing in every question here. Okay. So this is how we can find out the candidate key, prime attribute and non-prime attribute. This is how we can find out the closure here. I hope you understand this question. Now let's come back to this question. Now here you can see all attributes are part of candidate key. In that case, how we can go?
So can you repeat, please?
So here you can see if I want to find out candidate key for this relation R, but we observe that all attributes are on the right hand side here. So in that case, how we can proceed to find out the candidate key?
Find the closure, sir.
Yeah. So in that case, we have to go with that long method. First, take closure of A, B, C, D, E. Okay, so you have to check one attribute or combination of other attribute here. So what's the closure of A here? A only, right?
Yes.
What about B?
D,
So
B
B,
and D. B and D.
so B and D.
BD only. What about C? C
C,
only.
C
What
only.
about D?
D only.
D only.
E also. What about E?
A.
A only, right? So individual is basically not a key. So we have to go for a competition here. Then go with AB, go with AC, go with AD, go with AE, then BC, then BD, then BE, then we left with CD, then CE, then we left with DE. So this combination we have to go like that. What about AB? What's the closure of AB?
C. A, B and C.
A, B, C, but from AC we can get B here. Again, but from B I can get a D here.
D.
But again, from AD I can get E here. That's it. I got all the attributes here. It means what? AB is one of the candidate key. Now check with AC. What about AC? AC from I'm getting
E.
B, right? Now, if
E.
AB is already a key and I'm getting AB in the closure, it means what? It will give me all the attributes. AC is also candidate key. What about AD? AD will be what?
E.
AD, but from AD I'm going to get E, but from E I'm going to get what? A only. So ADE will not be a key here. So in that way, you have to take the closure of each and every combination and see which one is giving us all the attributes here. Okay. So this is how we can proceed here. So we can find out the candidate keys for this relation R. Okay, which candidate key we got already two candidate key, but there are more candidate keys you can find out. Okay, and you can tell me the answer on the discourse here. But the question is for R1. So here we need to find out key for R1. How we can do that? Okay, first, is this clear? Like how we can find out the key in the case of all attributes on the right side? So we have to go for the combinations of, like first go for individual, then combinations of the attribute here. And let's say, for example, we found out that C is basically will give us all the things. Okay, let's say assume that we are getting all attributes here, and we are not getting in the case of A, B, D, E. So C is basically a candidate key. Now, in that case, you don't have to consider C while taking combination. Just go with AB, AD, and AE. Because anyway, as C is basically a key, so AC will give me all the attributes here. So this will become super key. But we are interested in candidate key here. Okay. So you can reduce the your calculation here like this. Okay. Now first tell me about R1. How we can find out the key for R1 here? Yes.
So we will merge all the functional dependencies from the original table to this relation.
Yes. So tell me what will be the F1 here applicable to R1. So first always find out the functional dependencies applicable to this relation. That is F1. Let's say for example, tell me.
AD.
AD gives E.
Then
E gives A.
A gives A, like AD also.
Okay, then
That's it. Like
okay. So we have to find out all the applicable functional dependencies here. Okay. So from AD we are getting E, right? Then here we have E determine A, right? So that's it, right? E determine A. If I take a closure of A, I'm getting A. If I take closure of E, EA, D, D only, then AD, E only. Then if I take DE, so anyway, this will be part of this only. DE also determine E, I can say like this. Then Yeah. So these are the functional dependencies here.
AD
Like
and DE.
AD and
DE.
key here. Yeah. So you can see. So in this case, we have E and A, right? So only D is remaining. Now D must be a part of key here. Is D is a key? Can you see? No, right? So check for combination of AD and DE. So if you take a closure, we are getting all the attributes here, right? Of R1. So here we have two candidate key AD and DE. Okay, simple, two candidates key. So first, always find out all the functional dependencies applicable to that decompose relation, and then you can find out the candidate key for a decompose relation here. Okay, this is how you can do. So try to practice more here for finding out the candidate key, because in every question you have to find out candidate key only. Okay. Okay.
Sir, you can
Yes.
complete that, no, sir. What is left over in that?
So that's it. We just need to find out number of candidate keys applicable to R1 here. So if you see, we have the functional dependencies. So first we have calculated the functional dependence applicable to R1. We have two FDs here, and based on FD we need to find out the key here.
Only D is left, no, sir. Then D is the candidate key.
Yeah, only D we have left, you can see. Now, but D is not a candidate key here, because if you see, if I take a closure of D based on this, it will be D only. Now, go with combination of DE and DA, because we just have three attributes here. Now, if you take a closure, you are going to get what? ADE. Again, here also ADE. Okay, so all the attributes of relation R1. So it means what? R1 is having these two candidate key here, DE and DA. Okay.
Okay, sir.
Now we have discussing about decomposed relation. So how we can check for decomposition, or how we can decompose the relation? Yes, anyone? What is lossless decomposition? What's the requirement here? How to check for lossless decomposition?
After decomposing, if we join it, we should get the original relation.
Yeah, that is the correct thing here. So if I have this R1, R2. So I decompose the relation R into R1 and R2. So if I join these two relation back, I should get my original relation. That is basically lossless decomposition here. But how we can check? There are three conditions to check that. Can anyone tell me what are those three conditions?
R1 union R2 should be
cannot be null.
R1 intersection R2 cannot be null.
This should be equals to R. R1 intersection R2 cannot be null. Okay. Yeah, this should not be an empty set. And then R1 intersection R2 should give me either R1 or R2. It means what? The common attribute of R1 or R2 must be a key of either R1 or R2. And what does this second statement is saying? It means that there must be some common attribute. Okay. And what the first statement is saying? All attributes must be covered in R. Okay. R1 union R2. Let's say, for example, here we have A, B, C, D. If I say R1 is basically AB and R2 is basically CD. So if you go with the first condition, R1 union R2, so AB union CD, so that is the same ABCD, that is correct. But here we don't have anything common attribute, so that will be a lossy decomposition. Do you want lossless? So we have to add any common attribute here. Let's say, for example, B, and B is basically key for R1. So in that case, this will be a lossless decomposition. So always remember these three conditions here for lossless decomposition. Okay. And if we this is the case for those two relation. What if we have R and we have decomposed that into R1, R2, R3? How we can check? Let's say, for example, in Rn, how we can check?
Same thing, but the union and intersection would be for all the R1 to Rn.
So the first thing is that R1 union R2 till Rn. So it must give me all the attributes because we want all the attributes of relation R. The first thing is there. Then this condition is applicable to only two relations here. So we have to go with two relations such that there must be some common attribute. So you can go with R1 R3 or R1 R2 or R1 R4. Just check which relation is having common attribute. And if R1, let's say for example, R3 is having some common attribute and that is giving me R1 or R2, R3 here, then I can join these two tables here. So I will say R13 is basically what? Say R1 union R3 here, like that. Okay. So in this way, we can check for two conditions, two decomposition here, and we can join them back. So in this manner, we have to go for every decomposition. So once we join this R1 and 3, now we have to check with R13 intersection R2 like that. Okay. So please refer to my quiz 2 video. I have discussed quiz 2 revision video. I have discussed these examples in detail. Okay. How to
So
find.
the third condition means either R1 or R2 should have any primary key.
No, R1 intersection R2 must give me R1 or R2. It means what the common attribute of R1, R2 must be a key of R1 or R2 here. So whatever attribute
Okay,
will
sir.
be there in the common, so that should be a key of either R1 or R2. Okay. Now we can
Okay.
check that what is the common attribute we have. Simply take the closure of that common
Closure.
attribute and see whether you are getting R1 or R2. That's it.
Okay, sir. Okay.
Okay, great. So here we can see we have a question based on decomposition. So first tell me it is lossy or lossless. Database are represent course information instructor. Okay, okay. Then here we have functional dependency are decomposed to relation. This is given to us. So here we have R having this X Y Z W relation. Okay. Just in terms of statement we have mentioned, we have functional dependencies. We need to check for lossless and dependency preserving here. So first check for lossless. Which one is lossless here? Tell me, is option 1 lossless?
Yes.
So R1 union R2 is giving me R here, XY union YZW, XYZW. Yes. It's R1 intersection R2 is basically key of R1. Is this correct? Right. So for the first option here, we are checking first condition. R1 union R2 is basically a what? XY union YZW. That is basically XYZW, which is basically R. First condition got satisfied. R1 intersection R2, do we have common attribute? Y is common. Yes. But R1 intersection R2 should give me either R1 or R2. So we have to take the closure of Y and see whether we are getting R1 or R2. Are we getting a R1 or R2 based on the Y? Can you check?
No.
What is the closure of Y here? YW we have. After this,
X.
X. X Y.
X.
yeah,
Sorry, X.
this one FD. Okay, don't get confused. A different one. So here W will get X. So X W Y. So we have X Y here, right? So we are getting R1 here, right? Right. So it is basically a lossless decomposition. So here we have Y determine W and W determine X. So by which rule we can say Y determine X? Yes, anyone? We have 3-4 Armstrong axioms, right? So just refer to
Transitive.
Transitive.
Yes.
Y gives W, W gives X.
Yes. By transitivity, if A determine B and B determine C, it means what? A determines C here. So same thing we can say here, Y determine X, and you can see from Y we can get X. So R1 is basically here. So we are going to get R1. So Y is basically a key. So here it is a lossless decomposition. Lossless. What about option number 2? Just go quickly. 2, 3, 4. I'm not going to solve now. Tell me. Is option 2 lossless?
Yes.
So here we have union. If I take union, I am going to get X, Y, Z, W. Common attribute is basically W. If W is the key of R1, R2, let's see. From W, I am going to get what?
X.
X. So anyway, XW is getting covered. So this is also lossless. What about R1? This one? Option number
That's
3?
It's lossy.
lossy.
No, no.
Because there is no common attributes, right?
Yes.
Yes,
What
sir.
about option number 4?
Lossy.
How lossy? X, Y, Z,
Lossless.
W.
Sorry,
Z
lossy.
is not giving all the attributes.
Yes, sir. Lossy.
So from Z, what we are going to get? Nothing. So this is
Nothing.
also not correct. So we have option A and B as my lossless decomposition. C and D is not a lossless decomposition, but we want to find out dependency preserving as well. So we have removed last two options here. How to check for dependency preserving? Yes, anyone?
So please explain this one.
Okay.
Check
So
for
first,
dependency for each relation.
yeah. So write down the functional dependencies for each decomposed relation. So first we'll discuss about this option 1. So R1 is having XY, R2 is having Y, Z, W. First find out what? F1 here applicable to R1. So I can write X determine Y, right? I can also write Y determine EX. Can I write?
Yes.
We already discussed.
Yes, sir.
What about F2 here? YZ
Y
determine
determine
W.
yes, sir.
Again,
Y determine Z. Sorry, W.
Y determine W. So this is covered. This is covered. This is covered.
Only one is left. W determine X.
Now W determine X is remaining, right? Now is this we have to check. So this is remaining because W is in R2, X is in R1, so we have to check for this one. Is this how we can check then? Yes.
Sir, we will check like while if we union F1 plus F2, if we able to determine like W and X, and we will able to connect both of these functional dependencies, so it's like dependency preserver.
Yeah. So we have to consider F dash equals to F1 union F2, right? But
Yes,
this
yes.
F1 is what? All the applicable functional dependencies. So here we have calculated F1, but in F2, can we get more? Can we say W determine Y as well?
No, sir, as Y is. Yes, sir.
If I take the closure of W, will I get Y? Based on the parent functional dependency, W determine X and X determine Y.
Yes, sir.
Yes, sir.
Yeah, so I can write this one. So Y W, then Z is what? From Z we can get anything? No. So
Nothing.
YZ is there, WZ is remaining combination. From WZ what we can get? Y here. YZ मिलेगा WZ Y. From WZ can we get Y? Can you check? If I take the closure of WZ, from W I'm going to get Y. Yeah, anyway I'm going to get Y because it is there. So I can skip this apart as well because anyway we cover this one. So we have this got all the applicable functional dependencies here. Okay. Now if I consider F dash, that is F1 union. Yes. Yeah. So if I consider this one, so we have to take 1, 2, 3, 4, 5 all FD into consideration. Now, how to check whether it is preserved or not? Simply take the closure of W based on F dash here. So use all the 5 FDs here. So are we going to get X here?
Yes, sir.
Yes, yes.
From W, I'm going to get Y, and from
Y.
Y, I'm going to get X here. You
X.
can see X is present. So this is preserved. So option A is correct here, but it's MSQ question. Multiple options can be correct. Is option B also dependency preserved? Can you check now? Okay, first is the method clear? What we have to do? In the case of dependency preserving, write down these two decompose relation. Find out all the applicable functional dependencies based on the parent FD here. So you can see X determine Y was there, but I have written Y determine X also. So you need to check all the FDs which is applicable to R1 based on F here. Same thing we have done for R2 as well. You can see this is not given directly here, but we can infer by using Armstrong axioms, or directly you can take the closure of individual attribute like this based on the parent functional dependencies and see which attribute you are getting from R2 in the closure. So that attribute it will get determined. Okay, that's it.
Sir, I have a doubt that F1 does not contain W, but we only can generate Y towards X if there is W in between that. How can you write Y to X if there is no W in F1?
Y to X. No, that's what I am
Yes.
saying. While finding out F1 or F2, we have to take the closure based on the parent functional dependencies. So this is not the F here only you can see. If I look at all the functional dependencies for this based on this F, we can also add Y determine X here. Okay, because based on the transitivity you can see here. Based on the transitivity you can see. Okay. So you need to find out all the applicable functional dependencies to R1 or R2 based on the parent FD here. So find out all FD. Let me write it down. Find all functional dependencies applicable to decompose relation. Like for example, R1 decompose relation. Okay, for finding out the based on the parent FD, based on this F means parents function dependency, parent FDs here, this one, like that. Okay, so all the applicable functional dependencies here. For this also we have a tutorial. You can refer to that tutorial as well. Now what about option number B? Is this correct?
Yes, sir.
So here we have what XW, right? So if you look at here, XW is there, right? So R1 XW, R2 YZW. So F1 is what? X determine W. Yes, we can write down that. The W determine X. Yes, also we can write down that. What about F2? We can write down YZ determine W. W determine X already part of there. Y determine W. So all FDs are covered already, right? So we don't need to check here. So it means what? R2, sorry, option 2 is also a dependency preserved here. So that's it. So option A and B are the correct one here. Okay. So this is how we can check for the dependency preserving. So please try to watch the tutorial and solve the question based on dependency preserving. Always remember, we need to find out all FDs applicable to decompose relation based on the parent FD here. Otherwise, you are going to miss this FDs here. Okay, then you can say you are not going to get required answer here. Okay, so always try to find out FDs applicable to a decompose relation based on the parent FD here, like that. Okay.
Sir, if the relation is lossless, then it will be dependency preserving, or the
No,
vice versa.
no, we cannot say like that. We have to check. Okay.
No,
Sir,
for
option number
for
4
both.
is lossless or lossy?
Option 4 is lossy.
Lossy, sir. How?
Because why is Z? Z is common, right? If we
Yes,
take
sir.
the closure of Z, are we getting R1 or R2? No, here, right?
No, sir.
Only
Okay.
So, sir, we cannot say anything about dependency or lossless as a vice versa if question is given. We have to check it last.
no. We have to check for both the things.
Okay, sir.
Yeah. Okay, great. Now this is about we have discussed in week 5. Now normalization here, different normal forms. Okay, what happened? Now tell me different normal forms we have.
1NF, first, second, third,
Yeah.
BCNF.
So 1NF, 2NF,
Sir, is
3NF.
4NF also important?
Yes, BCNF
Okay.
and 4NF. Up to 4NF is very important. Now you just need to remember the condition for this normal forms. Rest is just the calculation like what we have discussed. Find out handed key, find out the prime attribute, non-prime attribute, check for condition like that. So what about the first thing, 1NF? What is the condition here?
It should have atomic value.
Multi-valued attribute.
No
No multi-valued.
multi-valued attribute
Yes.
here. So what do you mean by multi-attribute here? Yes, anyone?
Like phone numbers. One column can have
Addresses.
multiple
Yeah.
entries.
So phone number we cannot store 9991 number comma 88 another phone number like that.
Yes, like in the name, we can't store Riddhi, comma Sehgal.
Yes, like that. So how we represent this in ER diagram by which symbol? MVA. Double ellipse, right? That is what multi-valued attribute here. You can see multi-attribute by double ellipse here like that. Okay.
Yes, sir.
So simple. If in the question it is mentioned that all domains is having atomic values, it means it is in 1NF. Or always assume that it is in 1NF. Okay. Assume that it is in 1NF unless you have specified that there is MVA in this particular attribute or a table is given. In table you can see we have multiple values. In that case it is not in 1NF. Otherwise, if just R is given to you and then we ask for the normalization form, assume that it is in 1NF. Okay. Now what about 2NF?
Multi-value
Partial
means
dependency.
Yeah. So first it should be in 1NF, then no partial dependency. Now what do you mean by partial dependency? Yes, anyone?
No
No
prime
prime
attribute
attribute
should
can give non-prime.
target non-prime attribute.
Okay. So if we have this FD, X determine non-prime attribute. So this should be a no prime attribute. No, that's not a complete definition here,
Non-prime.
right? So we can say it's a what? What we can say about this? Yeah, subset of candidate key determining non-prime attribute is what partial dependency here. So if I say A, B is basically a candidate key, it means what A and B are prime attribute. So B determines C is what? So B is prime attribute, C is non-prime attribute, and so this will be a partial dependency here. Okay. So subset of candidate key. If I say A, B determines C, this is also prime attribute, but entire thing is basically a key here. So this will not violate partial dependency. This is not a partial dependency at all. Okay. So subset of candidate key is basically a prime determine non-prime attribute is what a partial dependency here. So first always find out the candidate key, then prime attribute and non-prime attribute. This is the first step you have to do in normalization questions. Okay. Now what about 3NF?
No transitivity.
No transitive dependency. What do you mean by transitive dependency here?
If A to B and B to C exist, we have to check for either uh, B is in prime attribute or
See,
not.
that is basically also transitive we can say, but in normalization we have a different thing for transitive dependency here.
So A to B. So the A difference of B minus A, like difference of B minus A, it should be prime.
So just remember this one, non-prime determine non-prime, right? If this FD exists, it means it is a transitive dependency here. This is what transitive dependency, this is not allowed. Okay. So
Or
let's say
the
for
recipe
example,
is
D determines C, If A, B, C, D are the relation, if A, B is the key, so both are non-prime attribute. So always find out non-prime attribute first and see if we have this particular thing here. If non-prime attribute determine non-prime attribute, this is basically a transitive dependency and it is not allowed in 3NF. Okay. So just check for this condition, that's it. What about DCNF? Yes.
Left side is super key.
Left hand side is super key of all relation for all FD here. Okay, so every function dependency, left hand side must be a super key. That is what the BCNF does. It's a more stricter form of normal form because it should be in 3NF first, then 2NF first, and 1NF first, like that. And now what about BCNF here? Sorry, 4NF?
No MVD.
No multi-valued attribute, sorry, dependency. Multi-value dependency, that is MVD. Now what do you understand by MVD? Yes. No multi-valued attribute here. So we generally define this by double-headed arrow like this. Okay. So if you want to check for alpha multi-determine beta here, so you can refer to the quiz 2 session. I have discussed that thing in detail. Okay. And in that I have discussed one important question also. You can refer to that. But here what we have discussed in that session, if you want to check if MVD exists or not, keep alpha value same. So take any two rows. So if you look at the slides, in that they have mentioned if T1 alpha equals to T2 alpha, then check for this condition. Okay, that's what we are doing here. First, we'll take two rows from the table and we'll keep alpha value same. So anyway, like two rows must have a same left hand side value. Okay, and then exchange beta value. Exchange beta value here. Okay, so in that case, we are going to get two new rows. If those two rows are present in the table, then we can say MVD exists. Otherwise, MVD does not exist. Okay, this is what we can say about the MVD here. So these are the previous sessions, I guess, previous term I have uploaded. I guess you can refer to this one. Where is MVD condition? Here we have, this is slides, okay. Dependency. What happened? Yeah, you can see here, right? So can we write? No. So see, if T1 alpha equals to T2 alpha, so take any two rows such that left hand side value is same. This is what we have written here. Then exchange the beta value. Beta means whatever the right hand side value we have. Now here you can see cost multi-determine book. Now, is this visible? Font size is fine.
Yes, yes, fine.
Yeah. So now let's take any two rows. Let's say, for example, this AHA and let's say this third row AHA. Okay, first and second row because we want to check for different value. So alpha value must be same for two rows such that we have this condition satisfied. But you don't need to remember this one because it depends on how you consider T1, T2, T3, T4 like that. So best way is take any two rows such that we have same alpha value, exchange beta value. So syllabus stat and another bit we have. So we are exchanging the beta value here. So this will be a needle pet, this will be a syllabus stat. Assume that we have exchange. Now we are getting two new rows, AHA, nether pet, and John D. So is this row present in the table? Yes, you can see row number 4 here. Here we got AHA, Silverstad, and William M. Is this row present? Yes, you can see row number 3 here. Okay. So then we can say MVD exists and you have to check this for every unique left hand side value. So once we have checked for AHA, check for OSO as well. So anyway, if you just interchange Silverstad with Silverstad, anyway, you are going to get the same rows here. So already it is in MVD exist here. Okay. So please watch the quiz 2 session. In that I have discussed the example in detail. We have solved one example also using this method. Okay, so please refer to that. Very, very important. Just remember these two things here. Keep alpha value same, exchange the beta value here. So this is MVD exists, and for 4NF, it's no MVD must be present there. That's it. Okay. Any question here? How to check for the conditions? Okay. So one important thing, any relation having just two attributes. So is this in 4NF we can say, or BCNF? Is anyone there?
Yes, sir.
Yeah. So like any relation having just two attribute, right? It is already in 4NF because only there are two possibility. Either A can determine B or B can determine A, or both FD will be there. In either of the cases, one of the left hand side is basically key only, right? Only these two things possible there, and in any case, left hand side will be a key. And MVD to exist, there must be at least three attributes. So at least three attributes are required for MVD to exist here. If only two attributes are there, there is no MVD in that particular relation here. Okay, remember this important point. Now let's try to solve this question here. Tell me. So first check for F1. If I use F1, is it in BCNF or 2NF or 3NF, in which normal form? Yes. If I just use F1 here for these books, then which one is correct here? It is in 3NF but not in BCNF, or BCNF. Which one is correct? So the first thing is what is candidate key here? If I just use F1,
Title.
Title.
title is candidate key, that's it. So prime attribute and rest all are non-prime attribute. Now here there is no MVA, so attributes are not the 1 and F. Do we have a partial dependency here?
No, sir.
No.
Only one FD is there. We don't have transit dependency as well because there is no any other FD. Only left hand side is the key. So this already is in BCNF. Can we say? Yes.
Yes.
Yes,
Yes,
sir.
sir.
Non-prime is determined. Non-prime is not present. Just F1 FD is there. So F1 is basically what? It is in 3NF. Here, this is what we can say. But not in BCNF. Is this correct? No.
No.
It is also in BCNF. Also in BCNF. So only option A is correct. But if I use F2 here, then tell me which option is correct. It is 2NF, 3NF, BCNF, or what for F2?
2NF.
So first, what is key here?
Title.
Title and
Author, genre, year. So which one is remaining? Title. So title, if I take a closure of title, I will get title, author, genre, and year. So title is basically a key, and remaining are non-prime attribute, right? So left hand side is basically my key here. So already this satisfied BCNF conditions. What about this one? What is?
Non-prime is giving non-prime.
Yes. So here non-prime attribute, determine non-prime attribute. What is this?
This cannot be 3NF.
Transitive dependency,
Transitive.
not in 3NF. It means it is in 2NF only, because do we have partial dependency here? No.
No.
no, sir.
Option B is correct here, not C. So A and B are the correct here. Okay. So in any normal form question, you have to just find out candidate key first, then find out prime attribute and non-prime attribute. That's it. And rest you have to apply those conditions like what we have discussed for each of the keys. Okay. That's it.
For BCNF, what is the condition, sir?
For BCNF, left hand side must be a key. So every functional dependency, left hand side must be a key here. Okay. If I put year dot title, so this is also a key, then F2, this will be in BCNF as well. Okay. So every FD, left hand side of every functional dependency must be a key. That's it for BCNF.
Candidate key, sir?
Sorry?
Is it candidate key you're telling? Key.
No. any key, super key. Okay. So
Okay.
candidate key is also basically super key only. Okay. All keys are super key, but candidate key is basically minimal super key. Okay. Okay. Great. Now this is question based on the 4NF. So here we have discussed 1, 2, 3. So first find out candidate key, prime attribute, non-prime attribute. Just check for those conditions. That's it. Now what about this one? Tell me which one is correct here. What is correct 4NF decomposition here? So every relation must be in 4NF as well as lossless. So whenever we talk about decomposition, now always remember it should be a lossless. Okay. Even though it is not mentioned, you have to remember decomposition is lossless only. So we have to check for decomposition such that it is in 4NF as well as lossless. Is option 1 correct?
No, sir.
So here we have a relation, right? What does this? They are saying we have 4 attributes. Intern can work in several projects. So intern code multi determines
Your
project here,
pen is malfunctioning.
and it can have several hobbies. So same, yes. Any doubt?
No, sir, you can proceed.
Okay. So when intern underscore code can have multiple project, intern underscore code can have multiple hobbies. This is what we have. And here we have intern code determining intern and name as well. Okay, this is given to us. It means what? This is dependent, intern code dependent, intern name, like that, right? Now is option 1 correct? So 4NF means no MVD. So whether MVD exists, any one of this exists in R1 and have at least 3 attribute. So you can see intern code project already exists. So MVD exists here, as well as intern code hobby as well. So R1 is not in 4NF. Same for R2 as well. Intern code and project exist here along with the hobbies. So R2 is also not in 4NF. What about option number 2?
It's also not.
R1 here you can say intern code project, not correct. For R2 we just have 2. So R2 is in 4NF, that is correct, but not R1. What about option number 3?
No, sir.
Same thing. The project we have hobby. So anyway MVD exists. R2 is in 4NF but not R1. What about option number 4?
Yes.
Yes, sir.
So here we just have 2 relations. So anyway it is in 4NF and we don't have MVD also. But if I take if I join this, will I get a lossless decomposition? You have to check that as well. So intern code, common. If I take intern code, intern name, I will get R1, so I can join this one. Then again, intern code is common. Again, if I take this one, so will I get a lossless decomposition? Again, intern code, intern name will be there. All right. So yeah, option D is correct here. Okay. So just remember in the case of 4NF, whenever you see a relation just 2 attribute, always in 4NF, no need to check for any condition. Even in this case also. In some question, they will ask which one of the options is in 3NF or BCNF. In any decomposed relation having just 2 uh, attribute, it is already in 4NF, no need to check for that. Okay.
Sir,
Huh?
can you explain the first option, please? I have problem doing 4 and F questions.
First option you can see in R1 we have this intern code project on hobby as well. So intern code project, that is MVD present. So if any relation if MVD exists, it means it is not in 4NF. Okay. So we have to remove MVD. So here also option number 2 MVD is present. Here in option number 3 MVD is present. Okay.
Got it, sir.
Okay.
Thank you.
So this is for a normalization form. Just remember these slides. Okay. This one. all this condition, and for MVD, just refer to a quiz 2 session, because in that I have discussed this thing in detail. Okay, this is about week 5, week 6, week 7. Just go through the slides. That is more than enough. What are the slides we have in this? Do we have any slides? Yeah, this also we don't need to go anything here. Just go through any Python DB, that one slide. That's it. One module. That's it. Then we have week 8. Week 8, we just have two important things. First one is binary search tree, and then we have magnetic disk question. Okay, so please try to watch tutorial on magnetic disks and write down the formulas, solve PAGA. That's it. You can expect simple question. In binary search tree, I hope everyone is aware about. So let me take one question: 8, 10, 1, 2, 5, 16. Okay. If I have this, if I want to construct binary search tree, how we can do that for this given sequence? First, we start with 8. Now, what about 10?
It will go on the left
Left
side.
side.
So simple binary
Right
search
side.
tree means
To the
what?
right.
If the element is greater than this element, it will go on the right side. If the element is less than this root element, it will go on the left side. That's it.
Left side.
Now 10 is greater than 8, so I will put 10 here. Now next element is 1. 1 is less than 8, so I will put on this side. Now next element is 2. 2 is less than 8, then I will go on this side. But again 2 is what? Greater than 1, I will go on the right
Right
side,
side.
like that. What about 5? Greater than, sorry, less than 8, greater than 1, greater than 2, that will be like this. What about 16? That will be like this, right? So you should be able to draw the binary search tree based on the given sequence. And the question will be like this: how many leaf node we have? So leaf node is basically we don't have any other further node. So here we just have 2 leaf node. Okay, or what are the elements of leaf node, or what are the nodes on the right side of this particular node 10, right? So this type of question you can expect. Or what's the height of binary search tree? Yes, anyone, what's the height of binary search tree here?
Log of h.
1, 2, 3. Here we have 3, right? So what are the elements at level number 2? So level start with 0, level 0, level 1, level 2, level 3, like that. Okay. So the first thing, you need to construct a binary search tree. Now based on that, you can simply select which option is correct. Okay. So 4 statement will be there, but first you need to construct a binary search tree, and based on that you can answer the question. Okay, that's it. So just focus on binary search tree and magnetic disk examples. Just write down the formulas based on P and G, and that is more than enough for binary disks here. Okay. So this is what we have discussed for week 8. So any doubt from week 1 to 8, you can ask now. This is what from my side. That's it. Okay. So
Certain value.
yes.
Sir, there are so many questions regarding this BST of keynotes child. Can you segregate the formulas for it?
Sorry. Keynote. That is basically for B tree and B plus tree you're talking about, right?
Yes, yes, sir. Yes, sir.
Yeah. So we'll discuss that in tomorrow's session in detail. But I
Okay,
guess
sir.
on Discourse, Mandeepa has shared the formula, like entire sheet they have she has shared. So please go through Discourse. There are a few notes
Okay, sir.
attached, okay, on Discourse for the this week's.
Sir, how to proceed from the tree to table?
From which tree to table we're talking about?
Let's say, sir, in the question we have to giving only tree. So, sir,
Hmm.
how to arrange in that manner? 8, 10, or 1.
Okay, if trees will be given, yeah, in some paper we have given the trees and we have given the options which will give me
Yes,
this
sir.
binary
Yes,
tree.
sir.
So in that case, you have to go option wise only. Okay.
Okay.
Yeah, because multiple sequences are possible for the same tree, right? So that can be MSQ question. So in that case, you have to go with option wise one. Okay, so that's it from my side. So tomorrow we'll discuss week 9 to 11. Okay, so 9 to 12. Okay. Okay, thank you then. Bye bye.
Thank you, sir.
Good.
Thank you, sir.
So PDF.
I will upload in the calendar. Okay.
Okay.
So do you want
Sir,
this
you are going to
annotated
take.
one also? Shall I remove
Yes,
this
yes.
one?
No, sir. We can do it with the annotated one, sir.
Okay, I will upload in the calendar. Same video.
Sir, are
Yes,
you
sir.
going to
Thank
take
you.
tomorrow's session?
When? Tomorrow 6 to 8 p.m. only. Yeah.
Are you going to take?
No, no. Bhaskar will going to take. Okay. Tomorrow I have CT session, so Bhaskar will take.
Sir, it clashes with our Mad One session.
Tomorrow.
Yes.
Okay, I will check with the Mad One team, or we can postpone to 8 to 10. Okay, you can check the
Yes, sir.
calendar.
Yes,
I
sir.
will check with the Bhaskar. Okay.
All right, sir. Thank you.
You can check the drive. I will upload this PDF there. I have uploaded. Just a second. I don't know how to view access. So can anyone just check the calendar and confirm whether you have access to that PDF or not? Let me check share. Yeah, I have to do to
It
anyone.
says request access.
Okay, wait. Yeah, can you check now? Abhishek Yadav. Can you check now?
Yes, sir.
Okay, great. Okay, thank you then. Bye.
Thanks a lot, sir. Good night. Thank you.
Thank you, sir.